And it's not just like maybe like 1 week and like 2 weeks later. We've also run these experiments like over the course of months. Like we've retested a model that, for instance, was launched 4 or 5 months ago, and we say, see, it still converges the same score. Or we've tested a model for like weekend versus weekday because we know that that's a concern. So we've still seen convergence of the same scores there.
What is the life cycle of evaluation? So let's say I'm a lab and I want to do evaluation with Arena. How does that start?
I guess even before that, we're not like the only place to evaluate, right? Like you can evaluate in many ways. And so the first thing labs might do is they have their own both public and internal static benchmarks. Oh, we know like we want to hill climb on this benchmark right now. How are we doing on this benchmark, or like humanities last exam or whatever? Or that's more public, but you have internal versions of these. So like the first is just like you do these internal benchmarks and see how it's performing. Then it's like, okay, now that we're satisfied on these internal benchmarks, let's go to an external benchmark where we don't have the test set, and it's like a data distribution that we don't have, and how do we evaluate on that? And so I think that's where we come in and become pretty valuable, is if we provide this like ever-changing test set basically, and it's on live human eval votes.
One confusion point that I get from a lot of the labs that are already working with, like we're dealing with some static benchmark, is Arena offline? Like how many inference do you guys need to get to this many votes? And my answer is like, I don't know, like because it's live. This is what is unique and fascinating about Arena, because we never force users to vote. Everything is organic. So we cannot really define like to get to a statistically significant point, how many inference do you need? Because we have a rough range, but we can definitely not say for determining, because that's the live and organic part. It's organic users coming with their fresh needs for AI. So we heard from all labs saying that, okay, the insight that you guys shared actually captured part of the prompt distribution that we didn't even realize exists. We didn't know people are using, for example, this image generation model for this 3D like scoping or something like that. This is what you can only get from like live traffic instead of like static benchmarks.
Yeah, exactly. Like I've gotten a lot of questions around, so like, can you just give us the prompts and can you do the responses and then you can like generate your leaderboard off that? But that's not how the leaderboard works, since where you generate, like the users are submitting whatever prompts they want to at that time. It's not like we can just extract the prompt and give it to that.
Okay, then they have decided, they have made their mind. We want to test this Arena. What happens next?
So we'll onboard the endpoint. We'll give us early access to this endpoint, and we'll onboard the model, make sure it has like enough latency, enough like GPU resource behind it, so that it can actually like support our like dynamic traffic pattern. And then from there, we'll basically like push it live. And so before doing this, we're testing this private model. We don't want the users to see that we're testing this model. Like how do you prevent that?
Basically, there's like code names, right? Like all the famous ones like Nano Banana, and we can basically hide models behind code names. And a lot of the questions that we got from labs and also sometimes from the community is that obviously people will try to poke the identity of a private model, asking questions like, who are you, who made you, and things like that. And there will be questions around, will these questions and votes for these questions go into the leaderboard and impact the score of a specific model? The answer to that is that we actually have a very comprehensive and detailed data pipeline to handle these kind of things, to identify identity leaking questions and filter them out from leaderboard calculation to make sure that the entire leaderboard calculation is fair and neutral.
We have a lot of filters in place to try to make sure that the leaderboard, the votes we're using for the leaderboard are legitimate. Oftentimes we see like bots just like voting a bunch to just randomly, or like some users who come to the platform don't actually care about voting, so they'll just vote like side A1, side A1, side A1 all the time. And so we have like these filters in place to detect like anomalous like user patterns like that, or like potentially like bot patterns. So we make sure that the votes that are actually contributing to the leaderboard are valid.
We can't share the exact number, but I would say like the number of votes that we got, the raw votes that we got from users, is like on a scale like much larger than the number of votes that actually goes into leaderboard calculation, all because of like the filtering that we have in place to make sure like the leaderboard calculation is fair.
Yeah, exactly. Like for instance, like we'll often release models with about 2,000 votes on the leaderboard. And so labs will ask us like, why you need like so many more like generations than that? Why can't we just give you capacity for 2,000 inference calls and that's it? And it's because it's this natural organic traffic that we then have to make sure it's filtered down into like actually high quality votes that then go into the leaderboard.
During this like private release phase is that labs will ask us, at what point do you guys feel like, okay, this model is ready to be released? Like what is our way of thinking about a model being ready to be released?
There's a lot of factors that go into this. We basically have a number of votes that we notice we need to collect in order to have a good sense of what the actual score, when the score will be stable. So for instance, for Kex, it's around 2,000 votes that we look for before we have even some sort of confidence the score is stable. And that's reflected in the confidence interval. So we have confidence intervals around these scores, which is why we have like a ranking range, for instance, and those confidence intervals shrink as we gather more votes. We want the confidence intervals to be sufficiently small before we are more confident in a score.
Okay, we have confirmed that the score is pretty stable. The labs confirms that, okay, they want to release this private checkpoint into a public checkpoint. Can you walk us through like how does that process really works?
We definitely want to make sure that like it's a fair process when converting private models to public models. Our public leaderboard is meant to be like fair and open. And so the way we approach that is we have to make sure that we confirm that the private model is the exact same as the public model that they release, whether it's via API or via the chat, confirm with the labs that it is the same model. And then if there's a public API, we'll also make sure that the score for the public API converges to the same as the private endpoint. So that's why you'll see the fill and gray tag on there, is that we've tested this privately or in early testing. So we got an initial score, but we still want to make sure that once it's public, as we collect more votes, the scores end up converging, for instance.
Yeah, totally. I think the bottom line here is that we want every model that is listed on the leaderboard to be the exact same model that we can access outside of the arena, either via API or like a app or something like that. This is like the essence of the leaderboard being fair and neutral. What we observe from labs is that they actually sending multiple checkpoints at the same time.
Yeah, so we'll often get like anywhere from 2 to like 6 or 7 checkpoints all at once or scattered throughout time. And we see a couple patterns here. But like one pattern we had is like we get 4 models at the same time. And basically the lab is trying to figure out which of these checkpoints performs well on a live humans actually voting on this, like what's actually performing well in people. Yeah.
Labs will have like different recipes towards like different endpoints. They have like a lot of knobs to tweak. For example, this one is more like security and conservative when it comes to answering questions. This one is probably more factual. This one is probably more on the less factual, but more like whatever your question you give to me, I'll try to answer it side of things. So they will have a lot of knobs, and they want to see what is a good balance when it comes to like human preference, like which candidate of all of these like combinations to feel like best. So that's why we kind of see like labs sending a lot of checkpoints at the same time, and they can see from the leaderboard, as we discussed earlier, different categories to zoom into, okay, how these checkpoints actually perform when it comes to human preference.
Or maybe even they have like different post-training recipes to like achieve these different goals, and they want to see like which one performs best. Yeah. And so there's a couple ways they go about that, right? It's not just like they can submit like 4 all at once and they're evaluating all 4 at the same time, but sometimes it's like an iterative process.
There will also be cases where like they will send in 2, and then like 2 weeks after the evaluation, they will look at the result and say, okay, actually we think we can do better. So they'll send in 2 more. One question that we get from labs all the time is that for the same checkpoint that I test 2 weeks after or versus 2 weeks before, will the score be actually very different because they are tested at a different time, right? And we actually internally, we did a bunch of experiments like this where we test the same endpoint across different time ranges. And we didn't observe that the score actually converges. So basically meaning that our leaderboard calculation, the entire regulatory mechanism is very stable when it comes to like evaluating a model's capability. It's pretty consistent across different time windows. So why is this matter? This basically enables labs to iterate on models at different time steps. So just as you said, as a lab, you can choose to send in all the endpoints at the same time. You could also choose to send in 2 for now and another 2 some other time. And you can still know that the comparability of these 2 batches is similar.
Yeah. So I think data quality is a very important question, especially when you have like the consumer, like it's a consumer app basically. And so we talk about like a bot filtering and like user boarding filtering. But another thing we do have is this expert category. that we've introduced. It's about 5.5% of the prompts and that we get, and we make sure that these are prompts that like people with experience in the field asked. So we want to make sure that these are experts and not just like a homework question, for instance. We want to make sure that this is high level of quality for these questions.
Basically, we use kind of LM as a judge as approach to classify all the prompts that we had get since day 0 of Arena. As you can see, like 5.5% means that we go the bar pretty high when it comes to like how we category into expert arena. In the general text arena nowadays, the models are pretty crowded. Like the scores are very close when it comes to like the top 20. But on expert arena, we can see like the gap is actually more obvious, and which indicates that expert is a better way to measure models' intelligence in general. Yeah,
exactly. Because like the expert questions are a lot harder and require more knowledge from the base model and the post-trained model. So because of that difficulty, you can see more separability there.
Yeah.
And that's why like expert as a category is pretty important. And the expert leaderboard is important to look at for the frontier models because you can actually separate out the top models.
Another question that we got about expert arena specifically is that what is the difference between expert and hard?
So we've had hard for a long time. It's something like 30% of our prompts. 30% is still a large number of prompts, especially when they're in consumer app. We wanted to make sure it is like expert was truly expert and not just like a hard question. So a hard question might be a homework question that's difficult. Like it might be, for instance, like your second year in college and you're getting this in your class. That might be a hard question. But expert, like you need to have like spent several years in field, you need to have domain expertise in this field, for instance. And so for expert, we see it like 5.5% of prompts as opposed to like 30% of prompts for hard. And there's also a large separability in expert as opposed to hard. And obviously as models get better, like initially there was some more separability on just the hard tasks, but models got a lot better. So they began like all doing pretty well on the hard. So we developed expert to make sure there was separability again between frontier models.
Expert definitely zooms more in on like economically valuable. And just as you said, like a person has to be in the field for a couple of years, like with a couple of years of experience in, for example, finance or healthcare, to ask this kind of question and to make judgment of this kind of question. So this is why we think expert is so unique, and the percentage difference is so big, like 5.5% versus 30%.
Yeah, exactly. Along with expert, we introduced these occupational tags where it's not a subset of expert, it's like a entirely separate tagging. So you can get occupational tags along with expert tags. Does this prompt come from a software engineer? Does it come from a healthcare professional? And does it come from a sportsman professional? We have a bunch of different categories. One of the biggest reasons labs work with us is that we have this very diverse user base, and our traffic distribution isn't static, it's always evolving. And so whenever labs evaluate with us, they get like a slightly different distribution of prompts and votes. And so it's constantly evolving benchmark essentially. And it's not just mental, it's a proper evaluation. And then we're also evolving on our side. We're making sure our data quality is always improving, and we're filtering out votes. And we're also always evolving our leaderboard methodology and our categories to make sure that we're moving along with the frontier, where the frontier of AI is going. And for instance, as models get more advanced, we introduce hard. And as models get more advanced, we introduce expert. And as more modalities like agentic modalities become more current, we introduce coding and like broader and more capability within coding and tool calling. And even the labs that do have their own direct consumer apps, they only have like their models essentially that they can maybe compare to. Whereas we should compare against all the frontier models and all models in general. Like every model can be good at something. So we can do that, like broad comparison, fair comparison against all lab and all models.